Ever wondered how the world would look if it was only two dimensions? Let's dive into that thought. You see, in our everyday life, we experience three dimensions: length, width, and depth. But imagine if we took depth out of the equation. What we'd have left are two dimensions, and this is exactly where 2D crystal structures come into play. Now you might be thinking, are these structures just theoretical? Not at all. They exist in materials like graphene, which is a single layer of carbon atoms arranged in a repeating pattern. Because of this pattern, the structure is incredibly flat, essentially existing in two dimensions. Imagine a sandwich, but remove the bread. What you're left with is the filling, spread out in a flat layer. That's a rough explanation of what a 2D crystal structure is like. So in a nutshell, 2D crystal structures are like atomic sandwich fillings, where the bread is nowhere to be found. Now you might be thinking, how can we possibly see these structures? And that's a valid question. In the realm of the tiny, our eyes are not the best tools. But fear not, because we have technology on our side. Scientists use cutting-edge tools like electron microscopes to peek into the atomic world, visualizing the atoms and their arrangements. Imagine a microscope so powerful it can see individual atoms. Moreover, these microscopes don't just take pretty pictures. They provide data, which scientists use to build mathematical models. These models, like architects' blueprints, detail the structure and properties of 2D crystals. They help us understand why these materials behave the way they do, and how we can manipulate them for our benefit. So while we can't see atoms with our naked eyes, we've devised ingenious ways to visualize and understand their world. Consider this: without ever seeing an atom, we've managed to uncover the secrets of these 2D structures. Alright, time for a quick recap. We've delved into the fascinating world of two-dimensional crystal structures, a realm where atoms arrange themselves in a flat layer, creating a repeating pattern. These structures, though invisible to the naked eye, hold immense potential in the world of material science. Two-dimensional crystal structures are not a new concept. They've been around since the inception of the universe, just waiting for us to discover them. One of the most well-known examples of a two-dimensional crystal structure is graphene. It's a single layer of carbon atoms tightly packed into a two-dimensional honeycomb lattice. Graphene, with its unique properties such as high strength and conductivity, has revolutionized several fields, from electronics to medicine. Understanding these structures is not a walk in the park. We need sophisticated tools to delve into their intricacies. Electron microscopes, for instance, allow us to peer into the atomic realm, revealing the repeating patterns of these structures. But seeing is just the first step. To truly comprehend these structures, we need mathematical models. These models, though abstract, provide a framework to predict the properties of these materials before they are even synthesized. This understanding can lead to the creation of new materials with properties tailored for specific applications. Imagine a world where we can design materials at the atomic level, fine-tuning their properties to suit our needs. This is not science fiction, it's the future of material science, and two-dimensional crystal structures are at the heart of it. So the next time you hear about 2D crystal structures, remember, they're not just a figment of some scientist's imagination. They're as real as you and me, just a lot smaller.